Hello, welcome to the video. In this video, we solve exercise number 4-18. In this exercise, a fast food restaurant is looking at their staffing for the lunch rush and running from 10 a.m. to 2 p.m. People arrive at walk-in by car or roughly scheduled bus as followed walk-in one at a time, and that is inter-arrival are exponential with mean of 3 minutes, and the first walk in occur as per 3 minutes past 10 a.m. by car with 1, 2, 3 or 4 people to a car with respective probabilities zero point 0.2, zero point 0.3, zero point 0.3 and zero point 0.2. Inter-arrival distribution as exponential with mean 5 minutes, and the first car arrive as per 5 minutes past 10 a.m. A single bus arrives every day sometime between 11 a.m. to 1 p.m. and the arrival time is distributed uniformly over this period. And the number of people on the bus varies from day to day, but it appears to follow a Poisson distribution with a mean of 30 people. So once the people arrive, either alone or in a group from any source, they operate independently regardless of their source. And the first stop is with one of the server at the order payment counter, where ordering takes the triangular processing time and payment then also takes the triangular processing time. And these two operations are sequential, and the first order taking then payment and by the same server for a given counter. The next stop is to pick up the food, and which takes uniformly distributed between 30 seconds and 2 minutes, and then the customer goes to the dining room which has 30 seats, and some partakers of the sublime visuals taking an enjoyable triangular distribution, and the time of the distribution is in minutes. After that, the customer walks fulfilled to the door and leaves. And the queue discipline is first in first out, and there is also a travel time that is as per 30 seconds, and after eating the people move more slowly and their travel time is now increased from as per 30 to as per 1 minute. The server at both order pay and picked up food have a single break, and they have shared on rotating basis. More specifically, 10:50, 11:50, 12:50 and 1:50. One server from each station goes on a 10 minutes break if person due to go on break at a station is busy at break time. And the staffing is the main issue at the restaurant, and currently there are 6 servers at the order pay station and 2 at the pick up food station throughout the 4 hours period. Since they know that the bus arrives sometime during the middle 2 hours, they are considering a variable staffing plan that for the first and last hours would have 3 at order pay and 1 at pick up food, and for the middle 2 hours would have 9 at order pay and 3 at the pick up food. Note that the total number of persons or on the payroll is same, that is 32. Under either the current staffing plan or the alternate plan, so the payroll cost is same, and what's your advice in this case? So in terms of output, observe the average and maximum length of each queue, average and maximum time in queue, and the total number of customers completely served and out the door. Make the plots of the queues to get into the order slash pay, pick up food and the dining room. Animate all the queues, resources and movement between the station, and you can also pick .plb picture library for human pictures and differentiate each of the picture appropriately. Okay, so here our model. So first insert the create module and rename it as the walk-in arrival. Change the entity type as walk-ins, and the time between arrival is random as per, that is 3 minutes, and entries per arrival is 1, and the first creation is take as per 3, and then simply click OK. Then add an other create module and rename it as the car arrivals, and change the entity type as star, and the time between arrival is random as per, that is 5 minutes, and the entities per arrival is follow the discrete distribution. So you can see it here, the 0.2 for the 1, 0.5 for second, 0.8 for third, and 1 for the fourth. So you can use this expression builder to create the current expression and click OK. And the first creation is ESPO 5. Add an other create module and rename it as the bus arrivals, and change the entity type as bus, and the time between arrival is constant in this case as mentioned in the case. That is, you can put a larger value in this field and change the units to minutes, and the entities per arrival is Poissonly distributed of 30. It's the parameter value. And the first creation is uniformly distributed with its minimum value of 60 and maximum value of 180, and then click OK. All these three type of customer move to the arrival station module. So you can insert the arrival station module from advanced transfer and click the station button and drag into the model window. Okay, so rename it the arrival station module, and the station name is arrival station and the station type is station. Then add the route module from the same template and rename it as the route to order payment station, which take ESPO 0.5 minutes, and the station or the destination type is the station, and the station name is order payment station, that is shown here. So first you need to add this station, that is the order payment station module, and the station name is order payment station and the station type is station. Simply duplicate this station and insert these two stations as well and rename it as the pick up food station module, and this one is the dining room station module, and rename it as the dining room station, and this one is the pick up food station. Then move back to this route module and select the station name, that is order payment station, and then click OK. Okay, so next add the process module from the basic process panel and rename it as the order counter, and the action type is cease delay, and add the resource, that is order payment server, and the delay type is expression, that is triangular distributed, units are in minutes. Okay, now add another process module and rename it as the payment counter, and the action type is delay release. Remember, in this case the action type is cease delay. You can check it out. Here is cease delay and this one is the delay release, and the resource is the order payment server, and unit to cease value is 1, and the expression type is triangular distributed, and the units are in minutes. So in these two process module can also be unit to a single process module by simply changing the delay type to expression, and then under the expression menu type the both distribution values like triangular distribution plus the process time of the payment counter module 2. So if you combine these two modules into a single process module, then this logic would also be works fine. Okay, that was the alternative method. Okay, now add another route module and rename it as the route to pick up food station, and the route time is ESPO, that is 0.5, and the station name is pick up food station, that is defined here, and the destination station is type is station. Click OK, and remember this station has already been added and this one too. So now add another process module and rename it as the pick up food, and the action type or logic is delay release, and the resource name is pick up food server, and that is uniformly distributed, minimum value of 0.2, sorry it's 0.5, and maximum value is 2, and the units are in minutes. Then add another route module and rename it as the route to driving room station, and the route time is as 4.5 minutes, and the station name is driving route station that is already defined here. Okay, now add another process module and rename it as the driving room, and the action type is seize delay release, and the resource name is dining room seat, and unit to seize value is 1. That is triangular distributed with its minimum value of 11, 20 and 31, and units are in minutes. Okay, then add an decide module and select which type. So if the entry type is in, and the second entry type is star, and the last one is definitely related to the bus, so no need to add. That also that automatically goes into the else side. So if the entry type is score, add an assignment module and rename it as the assign in fat picture, and entity picture type is picture dot in fat. If the entry type is the tor, assign tor fat picture, and this one is picture dot tor in fat, and the last one is the picture dot bus in fat. So you can also rename the entity picture type as you like. So how we can define all these three entities? You can define it under edit entity picture, and under this library here you can define entity picture dot bus in. This one is picture dot bus in fat, picture dot tar in, picture dot tar in fat, picture dot wat in, and this one is picture dot wat in fat. So simple, insert the basic process PLB library into this trace, and then change the entity pictures as you like. So if you double click on it, you can edit it. Okay, so that's it. Now add another route module and rename it as the route to exit station, and the station time is S4 1.0 minutes, and the station name is exit station, and exit station is defined here. That is the station exit station module, and station name is exit station. Click OK. Then add the record module and rename it as the count exits, or the type for statistics definition is count value, current value is 1, and the counter name is exit count. Click OK, and then finally exit the module. So this one is the complete flowchart of exercise 4-18. Okay, so now move to the basic process panel, and first move to the entity spreadsheet, and under the entity spreadsheet here you can see three type of entities come into the system: in, bus or car. And initial picture is picture dot in, picture dot bus in, picture dot car in, and these picture assignment is defined under this edit entity picture module. Okay, so it's done. Now move to the queue, and the queue discipline in first out for the three processes. Move to the resource module, and here you can see the three resources: order payment server, pick up food server, and dining room seat. So actually the case represent the two type of resource under these two resource menu. So that's why here pick the type based on schedule, and this one is again based on schedule, and the dining room seat is the fixed capacity, that value is 30. Under the under the schedule name, add the two schedule name, that is first one is the order underscore pay fits, then order underscore pay variable, exactly picked up fits and picked up variable for the rest, for the setting resource picked up fits and picked up variable. And these two uh, information under these two schedule name is defined under the schedule spreadsheet that will be discussed later on. Okay, the schedule rule type as per the case is the ignore type. Okay, move to the schedule spreadsheet, and here you can see all the four schedule names shown in this list. You can also define the schedule name here and then pick any of these schedule for the process type. I mean, if the order payment server, so first run the model with order pay fits, Then run the model again for order pay variable as prescribed in the text problem. Okay, so the type is capacity times in minutes, scale factor is 1, and under each of these schedule uh, processes add these durations. For first 3 duration is 50, then for 2 is 10, 9 for 50, 8 for 10, 9 for 50, 8 for 10, 3 for 50 and 2 for 10. These values are actually come from these problem statement. So if you read the statement again, you can simply uh, select these values and the duration count values that is shown in minutes. Simply conversion process is done here. Okay, so the pickup variable, it's the value of the resources are 1 0 3 2 3 2 1 0, and these are the duration values. Now move to the order pay fits. Okay, so the value is 6 for the first 50 minutes, and then the value is 5 next 10 minutes. Now add the pickup fits value, that is the resource capacity is 2 for the first 50 minutes and the resource capacity is 1 for the next 10 minutes. Okay, so now let's move to the run setup menu, and the number of application is 1. The application length is 4 hours and the base time units in minutes, and then click OK. Okay, now let's move to the animation part of the model, and you can add the animation as you like. So this one is the idle, this one is for busy, and this one is for inactive or fail state. For idle state, simply insert these boxes exactly for pick up food, and this one is the dining room queue or seize area. This one is the pick up, this one is the order pay. This one is representing the station, arrival station to the order payment station, then from order payment station to the pick up food station, and then from pick up food station to the dining room station to the exit. So move to here and then there. So these are the process queues. That's it. Or let's run the model with first requirement. Under this requirement, the order payment server is fits and the pick up food server value is also fits. That's it. And this one is the plot, and the plot is showing the order queue, pick up queue, and the dining queue. Or for order queue, the expression is NQ, that is order underscore counter dot queue. For pickup queue is NQ again for pickup food dot queue, and for dining it's dining room queue. Rest are the cosmetic changes, you can do it on your own. That's it. Now let's run the model. Let's slow it down. Let's run the model. So the model is working properly. Let's fast forward it. Okay, so here you can see the number out in system is 189, and the waiting time for dining room queue is 0.02, order counter queue is 3.2, and pick up food queue is 0.7, and its maximum value is 1.6, 19.3, or you can say 20, and 5.9, and you can say 6. And the number waiting is the 0.02 for dining room queue, order counter queue number waiting is 2, and pick up food queue is 0.6, and the maximum value is 3, 22, and 6. Okay, now let's run the model with variable type of capacity, and In that case, we have already defined the schedule name, that is order underscore pay variable, and pick up food server process is pick up variable, and the detail of these variable is defined under the schedule module as discussed already. Okay, now let's run the model again. Let's fast forward it to view the result. Now the number out is 190, and the waiting time for these three processes is 1.8, 4.2 and zero point 0.7, and the maximum value is 10, 22, 11, and the number waiting for these three processes is 1.4, 4.8, zero point 0.7, and the maximum value is 15, 28 and 6. And that concludes our exercise 4-18. Thank you.